Transformation, January 2015, question number 5. The diagram below shows triangle LMN and its image P triangle PQR after a transformation. I. Write down the coordinates of N. Alright, so this is N here, and we're asked to write down the coordinates of N. So the coordinates of N, now the vertical coordinate is 4 and the horizontal coordinate is 5. So the vertical coordinate is x is equal to 4 and the horizontal coordinate is y is equal to 5. So N has coordinates 4, 5. Alright, the second thing we're asked to do is says on the grid above, draw triangle FGH, the reflection of LMN in the y-axis. So we're asked to reflect LMN in the y-axis and label the image FGH. Here's what we have to remember. We have to remember that in a reflection, the object and image are on what? Are the same distance from the mirror line on opposite sides of the mirror line. So let's say that again. In a reflection, the object and image are the same distance from the mirror line on the opposite sides of the mirror line. So L, the mirror line, is the y-axis, and L is 1, 2 units from the mirror line. The image is the same distance, 1, 2, but on the other side. So this would be the image of what? L. Alright? And let us say that the image of L is F. So in a reflection, the object and image are the same distance from the mirror line on either sides of the mirror line. M is 1, 2, 3, 4 units from the mirror line. The image of M is what? Also 1, 2, 3, 4 units, but on the other side. So the image of MG is here. So in a reflection, we have to remember object and image are the same distance from the mirror line on either sides of the mirror line. Alright, so let's just rub this out. Alright, the next point is, the final point is N. N is 1, 2, 3, 4 units from the mirror line. The image of N, which is H, is also 1, 2, 3, 4 units on the mirror line, but on the other side. So here is where we have H. Alright, and we can just erase these lines. They're not supposed to be there. Alright, so once we have reflected all the vertices, we'll just simply connect them using a ruler. Alright. Alright, so LMN is the object and FGH is the image. So FGH is the image of LMN after a reflection in the y-axis. Alright, the third thing we're asked to do, it says using vector notation, describe the transformation which maps triangle LMN onto PQR. All right. So we want to know which transformation maps this triangle onto this triangle. All right. Which triangle? So the transformations are reflection, rotation, enlargement, and translation. Translation means to move in a straight line without turning. So if we look carefully, we can see that LMN was translated to PQR. Let's simply move it down in a straight line without turning. So I would say that triangle LMN is mapped onto triangle PQR by T, and T is what? This is what? 1, 2, 3, 4, 5, 6. By T, which is what? 0 minus 6. Alright? So T 0 minus 6 is my translation vector. The top value describes my horizontal movement, and the bottom value describes my vertical movement. The fact that the top value is 0 is telling me that I did not move the shape left, nor did I move it right, and that the only way I moved the shape was what? The minus 6, which is bottom value, is telling me that I moved the shape 6 units vertically downwards, or 6 units downwards parallel to the y-axis. Alright, so triangle LMN is mapped onto triangle PQR by T 0 minus 6, which is a translation of minus 6 units parallel. Let's have to write this out. So I don't want it to write neat. So by T, which is 0 minus 6, and this is a translation of minus 6 units parallel to the y-axis. Alright, and minus 6 is telling me that I'm going what? Down. If the bottom value of my translation vector is negative, it means that I'm moving the shape down. The top value is 0, which means that I did not move the shape left nor right. I only moved the shape 6 units down. So triangle LMN is mapped onto triangle PQR by T 0 minus 6, which is a translation of minus 6 units parallel to the y-axis. Now, next, the fourth thing we're asked to do is to complete the following statement. All right, so I wrote this statement down here. The fourth thing we're asked to do is to complete the statement. I wrote the statement down here, so that's going to complete it. And this says triangle PQR. So triangle PQR is this triangle here, is mapped onto triangle FGH. So FGH is the triangle over here. All right, so triangle PQR is mapped onto triangle FGH. All right, so let's complete. So triangle PQR is mapped onto triangle FGH by a combination of two transformations. First, triangle PQR is mapped onto LMN by, so want to see, a while ago we looked at the transformation that took LMN to PQR. Now we want the transformation that takes what PQR back to LMN. All right, in other words, what I want is the inverse transformation. All right, so if what we did to get LMN to PQR, what we did was move it 6 units down. So to get PQR back to LMN, we're going to move it 6 units up. So so first triangle PQR is mapped onto triangle LMN by a translation. And this translation is what, 0, 6, a translation of 6 units parallel parallel to the y-axis. So remember, we'll move it 6 units down to get it from LM to PQR. So now to get back from what PQR back to LMN, you have to move it 6 units up. The 6 being positive means that it went what, up. It went up. If it was negative, it would be indicating that it would have gone what, down. Then LMN is mapped onto FGH. So LMN, so this one is mapped onto this one, mapped onto LGH by a reflection in the y-axis. All right. So let's see if we can finish this thing. V says triangles PQR and FGH are congruent. Triangles PQR and FGH are congruent. And we are to state 2 reasons why they are congruent. So triangles PQR and FGH are congruent because 1, the sides are of the same length, and 2, the interior angles are equal. All right. So by saying that the sides of the same length, what we're saying is that the 2 triangles are of the same size. By saying that the sides of the triangles, corresponding sides of the triangle of the same length, what we're saying is that the 2 triangles have the same what, size. By saying that corresponding interior angles are equal, we're saying that that the 2 triangles have the same shape. So by saying that the lengths are the same and the size of the interior angles are the same, what we're saying is that the 2 triangles have the same shape and have the same what, size. And if the 2 triangles have the same shape and the same size, we say that the 2 triangles are congruent.